Let's learn how your Cloud Foundry applications are deployed on Bluemix. In this presentation, you will learn about the application lifecycle in Bluemix, how a Cloud Foundry runtime application is staged and deployed, where running application instances reside within Bluemix and how they get there, and how your application is accessed by users. The application developer manages the lifecycle of applications that are hosted on Bluemix using the console web UI, the command line, and other DevOps tooling. When a Cloud Foundry runtime application is deployed to Bluemix, the following high-level steps are performed. Upload the application components and metadata. Instantiate services if they're not already active and bind them to the application. Stage the application, deploy the application, and then manage the health of the application once it's running. When you're deploying a Cloud Foundry runtime application to Bluemix, you provide the code and any additional metadata needed to support the application. For a mobile app, Bluemix will deploy an artifact that represents the mobile application's backend, such as the services that are used by the mobile app to communicate with the server. For a web app or REST-based API, you deploy an application that will bind to a port and process HTTP and WebSocket requests and communicate back to the calling client. In either case, the choice of programming language is up to you. Many programming languages are supported by Bluemix build packs and runtimes. Let's look a little more deeply at where your app resides. This figure shows the execution component of a VM, known as a cell in the Cloud Foundry Diego architecture, that has multiple apps deployed. Each VM uses containers to separate and protect the apps. Each application in Bluemix Platform as a Service is associated with a build pack. A build pack is a collection of scripts that prepare the application for execution on the target Platform as a Service environment. A build pack gathers the runtime and framework dependencies of the application, and then it packages them with the application as a droplet that can then be run within the container. In each VM, the cell rep operates as an application manager, communicating with the rest of the Bluemix infrastructure and managing the apps that are deployed to the VM. This slide shows details of the staging and deployment process when using a build pack with Cloud Foundry. At the command line, the developer enters the directory containing the application and uses the Cloud Foundry or Bluemix CLI to issue a push command. The CLI tells the Cloud Controller to create a record for the application. Then, the Cloud Controller stores the application metadata. Application metadata can include the app name, the number of instances the user specified in the build pack, and other information about the application. Before uploading all the application files, the CFCLI issues a resource match request to the Cloud Controller to determine if any of the application files already exist in the resource cache. It omits these that are already in the resource cache and sends the rest of the app artifacts to the Cloud Controller. The Cloud Controller stores the application package into the blob store. Then the CFCLI issues an app start command. The Cloud Controller issues a staging request to Diego, which then schedules a cell to run the staging task. The task downloads build packs, and if present, the app's build pack cache. It then uses the build pack to stage the application. The Diego cell streams the output of the staging process so the developer can troubleshoot the application and any application staging problems in the terminal. The task packages the resulting staged application into a tarball called a droplet, and the Diego cell stores it into the blob store. The task also uploads the build pack cache to the blob store for use the next time the application is staged. Then, the Diego Bulletin Board System, or BBS, reports to the Cloud Controller that staging is complete. Staging must complete within 15 minutes or the staging is considered failed. Then, Diego schedules the application to run as a long-running process on one or more of the Diego cells. Once started, the Diego cells report the status of the application back to the Cloud Controller. After it's running, whether it has a web interface, such as for a Java or Node.js app, or other REST-based services, such as mobile services exposed publicly to a mobile app or an API, users of the app can communicate it with by using normal HTTP requests. Each app can have one or more URLs associated with it, but all of them must point to the Bluemix endpoint. When a request comes in, Bluemix examines the request, determines which app it is intended for, and then selects one of the running instances of the app to receive the request.